This is a short YouTube to explain the concepts of global versus local in your variable definition, static and automatic, and the difference between parameters and arguments, because I'm seeing a lot of misunderstanding in the homework. So this is what we're going to talk about in this short YouTube. Okay, so first of all, let's talk about global versus local. So this is just a general program here, nothing real exciting happening. But I have in the beginning of the program the compiler preprocessor directives. You guys are already familiar with that. You have no choice where you put this. It happens in the beginning of the program, and the compiler uses it before it ever begins compiling the actual program. Then you have this area right here where you put your function prototypes. So function prototypes is kind of a definition of declaring a variable. It's kind of it's a function, not a variable, but you're setting it up, you're declaring it so that the program can use it. Then you have your body of your main, and then maybe you have functions at the bottom down here, which these functions don't work unless you've declared a function prototype up above, which is similar to a variable declaration. By the way, you don't have to have a variable declaration if you take the whole function and put it before main, because the program is compiling, it's going through sequentially, and if it sees the definition of the function before it sees main, the function is already defined. So, but don't do it that way. It's confusing to look at when main is at the very bottom of your program. So, so when you make some variable declarations, for example, I'm in main and I've declared an int I right here, and I've also declared an array. These variables are local. So they are defined within the function, and they can be accessed only by the function that defines it. So the scope of that variable is within the function that defines it. You could put automatic int I, but by default local variables are automatic. So you don't have to write automatic. So that's going to come into play in a moment when we talk about static. So anything that you define up here at the top of the program before main are global variables. So whether that's a function or a variable that you've declared. So they're defined outside the main function or other functions. So this is not within any function at all. And some compilers need the word extern to go before the definition. So when you define something as global, it's accessible anywhere within the program. So, for example, instead of having int I being within main as a local variable, control copy, control X, I could have declared int I up here, and now it becomes a global variable accessible anywhere within the program. However, use of global should be avoided. Do not give variables more privileges than absolutely required. And if I see you doing this in your program, I'm going to take off for it. Your book also mentions this. So there is no reason for me to declare int I outside of main and make I available to both the main function and my show phrase function. No reason whatsoever. So it should not be a global variable. It's also confusing later in programming, because if a variable is declared, it's not visible within the code easily. So that's another reason not to make external variables. So if I put it up here, it's global. It's also external. Putting int I up here is global and also called external. So let's talk next about the use of static. So I just said local variables have an automatic storage class, that is, and you don't have to write the automatic. It automatically, the program is that way by default. So the local variables are automatic. They're destroyed upon leaving the function. A static variable, on the other hand, does not get destroyed when the program execution leaves the particular function. The memory of the variable's value will be retained during the entire program execution, and I have a little example to show you. So I've declared from the last example, I have the show phrase function, but I also declared a static variable int count equals 0, and I'm going to print, every time I call the function, I'm going to print the value of count, and then I'm going to increment count. So you would normally think if this was not a static variable, every time you called phrase, count would be 0, correct? But this time, it's been declared as static, so let me show you the rest of the program. So in the rest of my program, I'm going to call show phrase twice, and show phrase has that static variable count. And when I run that program, I already have it compiled. It'll say count equals 0 and count equals 1. So the value of count was retained after I departed from the function, and then the function was called again, but it remembered the value of count, and that the count had been incremented. So that's when you would use an example of when you would use a static variable. It's very useful for counting how many times a particular function has been called. I do not have a good example of another reason that you should use a static variable. As a matter of fact, normally you would avoid using a static variable. You can also have a static function. So here I have a function that's been declared as static. We don't use this yet, but later when you have several different .c files and you want to link them together into one executable, which you can do, we'll be linking several C files together into one executable. This is when you might want to use the static modifier class, static privilege modifier. So if you declare a function to be static, then it means that the particular function is only going to be visible in the source file in which you define it. So a particular C file, which is a particular source code that you have, and you've defined this function, if you declare it to be static, only that C file can use it and not other C files. Because normally if you declare a function, they are by default external, because you've declared them outside of main, right? So other C files that are linked together would be able to use the function, but if you don't want that to occur, then you have to declare it to be static. We'll see this again later when we put several C files linked together into one executable. And just a last little review of some of the terminology. You've seen this before. I'm just going to re-emphasize it. When you define a function, the items enclosed in the parentheses that say are called the parameters, and they're separated by commas. But parameters are basically a placeholder in the function definition that specifies the type of value that should be passed to the function when it's called. So int, doubles, whatever. Those are the parameters. An argument is the actual value passed to the function corresponding to a parameter. So when you call the function, then you are passing an argument into the function. And then we talked about pass by value. That's where perhaps you are calling the function and it needs an int or a double. And then there's pass by reference. So pass by reference is you are referring to something that the function is going to use, and we did that when we worked with arrays. So I think that is the summary of things that I wanted to just kind of summarize that have intermittently showed up in the past two chapters. I think it's good to put a perspective on it and summarize it, especially this slide. This difference between something declared as with global privileges or a global storage class versus something with local privileges or local scope. Keep it local in your programs. I will emphasize avoid the use of global. And let's see. And by default, a function that's not been declared static is going to be accessible by any C programs that are linked together in a compiled program. Okay, 10 minutes, that's okay. Bye now.